Welcome to Vet Review. In this video, we are going to differentiate between the radius and ulna of horse, dog and pig. So first, let us start with the radius and ulna of horse. The first point that you're going to see is that in case of horse, the ulna here, it is not as big and developed as compared to that of the ox. So see, in case of ox, the ulna is much longer than the radius. Yes, it is ill developed, it is not as developed as the radius, but in length it is longer. But in case of horse, this is not the case. You can see ulna is only this much. Okay, and because here the ulna is big, it forms two interosseous spaces, right? It has two interosseous space, and then we have the styloid process here. But in case of horse, only one interosseous space is present. So the first point is only one interosseous space, the proximal interosseous space is present. In case of, actually we don't use the word proximal because there's just one. In case of cattle, we say proximal and distal because there are two. See here, you have one and you have two right here. Okay, so in case of horse, only one interosseous space is present. Second thing that you can see is that the radial tuberosity is very well marked and it is much developed as compared to that of the ox. So this is the radial tuberosity. You can see in case of horse, it is very much developed. So radial tuberosity is well developed. The third points are here at the distal end. So in case of cattle, you must have seen that the facets for the articulation with the proximal row of carpal, they are oblique in direction, right? They are placed obliquely. You can see them here. In case of horse, that is not the case. The facets at the distal end for the articulation with the carpal, more specifically the proximal row of the carpal, are not oblique. Facets aren't oblique. Then we have superior check ligament. Superior check ligament is present in case of horse for providing more stability, and because it is not present in case of ox, here there is no insertion or attachment point for the superior check ligament, but because it is not present. But in case of horse, it is present. So where it is present, I'm going to use this model. It is of ox, but I think I can show it here. At the distal 1/3 of the posterior border, this is the posterior border, so distal 1/3 of the posterior border near to the medial surface. Okay, so this is the posterior surface, sorry, not border, posterior surface. This is the medial surface, and near to this border between the two surfaces at the 1/3 distal part of the proximal surface, you will see a point, okay, a rough surface for the attachment of the superior check ligament. Okay, so this has attachment at distal 1/3 of the posterior surface, at distal 1/3 of posterior surface. Okay, so this is it for the radius and ulna of horse. Now let us come to the dog. So the first point that you're going to see is that radius and ulna are two separate bones. Okay, so unlike that of ox and horse that you can see here, they are not fused. See how big the interosseous space is. So again, there is only one interosseous space. It is very big because they are not fused together like in case of horse or ox. Okay, so in case of dog and in case of pig, radius and ulna are two separate bones. They articulate with each other using the facets that I showed you in ox, and they also have interosseous ligaments to join them. Okay, this is one thing. Now the first point that I'm going to write is shaft of radius is convex dorsally and medially. Dorsally and medially. Okay, so the radius is a little bit curved in shape in case of dog. The second thing that you can see just in the radius is that the styloid process of the radius it is well developed. Okay, or I can say the medial border projects as styloid process of the radius. Okay, so in case of ox, we discussed that we have styloid process of the ulna. Okay, in some text this point is also known as styloid process of the radius, but it is not developed. But in case of dog, you will see that the medial border here, this medial border will project downward as the styloid process here. Okay, now we will start ulna actually. So the third point is that the ulna is placed, or it crosses the radius bone medial laterally. Okay, mediolaterally. Ulna crosses radius mediolaterally. Okay, so I think you can see that in this diagram, this is left radius and ulna medial view. Okay, so it is starting from the medial side, but it is ending at the lateral side. So in case of ox, horse, you can say that this is placed posterolaterally like this. Okay, there is no portion that is coming to the medial aspect. But in case of dog, the ulna starts from here and it kind of shifts to the lateral side. Okay, so it crosses the radius mediolaterally. Okay, this is a differential point. Fourth thing is the olecranon process is grooved. This is very important point in case of dog. Olecranon process is grooved and it projects 3 prominences. Okay, so again I'm going to use this model. This is of ox, but I'll show you what I mean. Here you can see that this is just plain because this is of ox, but in case of dog there will be a groove directed craniocaudally, or you can say antero-posteriorly. Okay, and what it will do, it will create 3 prominences. How? One is the summit and 2 small tubercles and placed anteriorly. Okay, so you have this here, we have a groove, so you have 2 prominences here and 1 big prominence here. Okay, so olecranon process is grooved, so it will be a 3 prominences. The posterior one is summit, it is the biggest, and anteriorly you will have 2 tubercle, 1 on each side, 1 on lateral, 1 on medial side. Okay, now the last thing is with that articulation. So remember, in case of ox, I have said that there are 2 facets on the proximal surface of the radius and they articulate with the 2 condyles of the humerus. But in case of dog, only the only the lateral condyle articulates with the radius. The medial condyle of humerus articulates with ulna in this case. Okay, so in case of dog, because the ulna is well developed, the medial condyle of the humerus, it articulates with the facet on semilunar notch. Semilunar notch. So what is semilunar notch? Here, this is the semilunar notch. It is completely articulating with the radius here by 2 facets. But in case of dog, what will happen? You will have a small facet coming out of the semilunar notch here. Okay, so only the medial condyle of the humerus articulate with semilunar notch of ulna, and the lateral condyle of humerus articulate with the facet on radius. Now last is the radius of pig. Okay, so first thing is that the radial tuberosity is represented by a rough area. So radial tuberosity is not that prominent. Okay, it is just represented by a rough area. Second thing, the facets for the carpal are concavo-convex in shape. So the facets are like this. Okay, facets, but when I say facets, I mean at the distal end. For the articulation with carpal are concavo-convex. Concavo-convex. Third thing is that the vascular groove is very wide. Vascular groove is very wide. Okay, so what is vascular groove? In case of ox, you can see this groove is called the vascular groove. In case of pig, see, this is the vascular groove. It is very wide when compared with that of ox. Okay. Now let us come to the proximal extremity. So the proximal extremity is bent medially in case of pig. So this is the proximal extremity of radius and ulna. So they are bent medially. Okay, so this will be bent medially just like this. Okay, there's a curve, medial curve, it will occur here too. Okay, so the proximal extremity will be bent medially and the lateral surface is convex. Lateral surface is convex and marked by a oblique ridge. Okay, and marked by an oblique ridge. We are talking about ulna. Okay, so the ulna of pig is very prominent bone. Okay, it is much more massive when compared with that of other animals. So in case of ox, see, radius is much massive as compared to the ulna. In case of dog, the radius is massive when compared to the ulna. In case of horse, the difference is actually like 10 times. You can say that ulna is very small, very less developed, radius is very well developed, very large. But in case of pig, it is inverse. Radius is well developed, but it is much smaller, much more delicate when compared with the ulna. Ulna is very big, very massive. So the lateral surface is much more convex and it is marked by an oblique ridge. Okay, you will have an oblique ridge down here. So this is it for the radius and ulna of horse, dog and pig. I hope you found this video useful. If so, then please leave a like and leave a comment down below. And if you haven't, then subscribe to my channel. Thank you.